Hello, this is Joe Ambroscotti again for North Atlantic. I'm the International Applications Engineer, and I have a customer overseas that would like to see how the P8 operates with the embedded soft panel. We're going to be looking at the 76C2 manual since that's the um, motherboard that he has the P8 on, and we're going to be operating the embedded soft panel with a different board, which is a 64C3, and it basically there's very little difference in how it operates between motherboards. So let's take a look at the function, the manual modules that are on the board, and you can see there's quite a few, but the P8 is what we're interested in today. There are 4 channels: async, synchronous, and synchronous mode is it operates at 4 megabits per second. Async, it runs 1 megabit per second for each channel continuously. Let's go to the description of the. And there's some other configurations where you can actually set up a half duplex operation. There's multi-drop for 485. We do have pair flow control for hardware connectivity, and there's also some general purpose I/O depending on how you set it up. Let's just take a look. Just emphasize the module actually it powers up in a certain configuration, and we're going to be operating in a loopback mode at 9600 baud with 8 bits and 1 stop bit. So let's take a look at the registers. Let's look at some of the key registers. There's the buffers, the receive and transmit, which are 32 kilobytes for each buffer, whether it be transmit or receive. The registers after it will actually tell you how many words are in the buffer, which is handy. So you don't have to try to read, see if there's anything in it. You go to the number of words registers to find out how many words are in the transmit or receive buffer. Makes it easy for doing some intelligent handling of the communications. Now, the protocol register actually sets up whether you can do async or synchronous operations. The clock register actually sets up whether you're going to do internal, external clock for synchronous operations. So today we're not concerned about where the clock is coming from, because we're going to be operating asynchronous. So interface levels. Interface levels is an important register because that's where you're going to be dealing with whatever RS level, voltage levels you're going to be dealing with, or whether it be loopback, or if you have to set up a half duplex configuration. And there's some other unique features on the P8 that the interface level register is involved with. Configuration low, I believe, is mostly there's two operations here. There's a hardware flow control and some X on X off operation for async. It can be also for synchronous too, but primarily a lot of the options on the configuration low register is asynchronous. Configuration high, essentially everything here is for synchronous operation. Control low. Control low is there's a couple of unique operations on the control low register that it controls. Some I/O, you actually can twiddle some general purpose I/O, clearing the FIFO. But the real important configuration is if you're running asynchronous, and you're running half duplex, there's a tri-state transmit line. In other words, when the transmission is over, the line will go tri-state. So there's something in the control low register that you need to be concerned with if you're running half duplex. Let's take a look at the control high. This is an important register. We'll be working with this. On the transmit side, there are two bits in this register that is important. One is the transmit initiate and transmit always. If you were to fill your buffer up and had the transmit always enabled, every time you wrote to it, that word that goes into the transmit buffer will be outputted as soon as it's written. The transmit initiate operates different in that you can fill the FIFO, read the number of words register to find out, or to make sure that the number of words that you're transmitting, and if the value equals the number of characters that are in the buffer that you put, then you can put a 1 in this first position, and that will transmit. And also the receive enable. So you got to be careful how you handle this register. Our firm software or our APIs handle this appropriately. So let's go back to the data configuration register. That simply sets up the number of bits and the stop bit and parity and so forth that you need to be aware of, and some other synchronous information on setting up the data that's going to be transmitted or received. And last but not least, the baud rate register. It's a 24-bit unsigned register. So to set up 9600 baud, you're concerned with the upper 20 or the lower 24 bits, that is. So let's do one more step, and that's to take a look at the connections. For RS-232, these are the columns that you're concerned with. You can see you can set 422 or 485, which is a differential, and that you can, if you configure it, you can use the transmit and receive. If you're setting it for synchronous operations, external clock, here are the clock pins. Likewise, there's also hardware or paired flow control setups on the different paired channels. If you have any questions about, you can ask. But we're going to concentrate strictly on asynchronous. But here are the connections for that. So let's go to the embedded soft panel. Just get a little used to operating with this. First thing, if you want to know what version of the panel you're working with, you can go to the help, and this window will pop up and it'll tell you the version that you're working with. It's always important to know. The other thing is the configuration. In this example, like I had mentioned, I'm going to use a 64C3, and I'm going to be using it in a standard Ethernet connection. It's a VME card that has P8s on it, and it is standalone in a chassis. There's no motherboard. I'm talking to the board directly to the 64C3. So let's connect up to it. When you connect up to it, you can see that I have several P8s. We're going to work with the first one. Selecting that module brings us up. Let's take a little tour of the panel. You got your configuration screen. It's kind of segregated by the types of things and channels that you want. You can always refresh to read what the values are. We're going to be running loopback. Board was already powered, and that's why it came up in this configuration. So it actually read what I was working with. Normally it would come up in not sure how it initially comes up. I think it's in tri-state. Let's take a look at that. If we initiate a software reset, close this out. We got to get out of this because the communication, once you do a soft reset, the interface to the Ethernet on the 64C3 is, you have to reestablish communications to it. So again, let's connect up to it. And it does come up in tri-state. So we're gonna set it up for loopback, and we're gonna leave everything else alone on this. The control, again, you can refresh, but we want to enable the receive. You don't have to enable the receive on the other 4 channels. So we're just going to work with the first channel. Basically, there's nothing else is set up. There's the status, and you do have I mentioned watermarks or thresholds within the FIFO. Their status registers. These are all the status registers. We're not going to go over the details of the statuses today. We're just going to operate, the P8 from startup, and also the interrupt statuses, and whether you've enabled them or if you've enabled them, whether you have a status pending or whatever the case is. But be careful on your statuses. Statuses are not only latched, but they're buffered. So if a status occurs and gets latched, and another status occurs, and you read the first status, that second status will be moved into the status register from the latch register. So we have latched, buffered status registers, and it's a good reason, because if an interrupt comes in and something comes while you haven't serviced it, at least ways you'll be able to see that something happened during an interrupt. Let's take a look at setting up a transmit. This enables the software to read the buffer. I happen to have a I don't see it. Let's get some data up here. Open data. There it is. All right, let's put something in the buffer. .66. Now, this will load it, but if I read, I'm not going to read anything. Then I transmit it. That's that one bit in that one register in the one of the control registers that when I initiate, it sent the data. Now, if I add some characters and I send it, I believe if I read the words in FIFO, it would read 69 in whatever hex value 69 is. And if I read the receive buffer, it's not going to have it until I initiate the transmit. And then I read. And there it is. So basically that's it. That's how simple it is to initiate a transfer. Okay. Thank you. If you have any questions, send me an email. jabruscati@naa.com. That's JABRUSCATI @NAII.com.